Hi, so for today we're going to talk about integration by trigonometric substitution. And we have the following formulas for us to integrate some integrals using in trigonometric substitution. And we have to memorize all of these formulas. And if the integrand has the following form, for example, the integral has this form, okay? For example, square root of a squared minus x squared, then we're going to substitute x is equals to a sine of z, where a here and b here, actually for the following formulas, are constants. Okay? So if we have this for letter b, the integral has this form, square root of a squared plus x squared, we can substitute x simply as a is equals to x is equals to a tangent z. And of course, for letter c, square root of x squared minus a squared, that is not the same. That is not the same with letter a. Okay, the variables flip over, wherein here the x squared is the first one minus a squared. We can substitute x is equals to a secant z. For letter D, if the integrand has this form, a squared, square root of a squared minus b squared, meaning to say that the coefficient now of x squared is not already 1, okay, here, because b is another constant, we can substitute x is equals to a over b sine z, okay? Again, this is only a, this is only b, sine z. So as you can see, this is a general form of our first formula. Because here, we have a over b, here we have only a. Why is that? Because the coefficient of x squared here is considered as 1. So the general formula of this, of the first, is actually this. Okay? So it so happened that the coefficient of this is 1. So a over 1 is simply a sine z. Okay? So for letter E, we have the square root of a squared plus b squared x squared. Okay? We can substitute x is equals to a over b tangent z. And again, this is a general form of our letter B formula. Okay, where again is the coefficient here is 1, so a over 1 is simply a tangent z. But if the coefficient is not 1, but rather greater than 1, we need to use this formula. Okay, and another, for the last one, we have the square root of b squared x squared minus a squared. That is equivalent to x is equals to a over b secant z. Again, this is the general format of the our expression. Okay, so let's try to solve some problems. For number 1, we have the integral of dx over x squared times the square root of 4 plus x squared. So what are we going to do is to identify first the integrand. The integrand has this following format, square root of 4 plus x squared. If we're going to look at our formulas here, square root of 4 plus x squared plus, so the coefficient of x squared is 1. So these 3, d, e, f, we cannot use that. Okay, but rather we can use the letter B formula, wherein it has a form of square root of a squared plus x squared. Then we're going to substitute x is equals to a tangent z. So this has a form of square root of a squared plus x squared. Okay, so now what are we going to do is we're going to simply what? Let x is equals to a tangent z, where our x or a here is this 4. Take note that this is already squared, so that is a squared. To get a, we could get the square root, that is 2 tangent z. This is very important. This equation is very important because you have to from this equation we can derive the triangle. Okay, so by the way, in this integration by trigonometric substitution, we're going to use a right triangle in solving this integral. Okay, so we can how can we write that right triangle? It's based on this equation. So from we can get tangent z. Okay, we can isolate tangent z, and that is basically x over 2. And if we're going to create a triangle, a small triangle here, right triangle, okay, wherein this is the hypotenuse and this is an angle, we call that by convention the angle z or the z. Okay, So, from this relationship, tangent z is equal to x over 2. So, for a right triangle, we can actually assign this on the sides of the triangle by what we call the SOHCAHTOA. Okay, tangent z is TOA, so it means opposite over adjacent. So, this is the z, okay? This is the z angle, so its opposite is this side. So, this must be the x, and its adjacent side is 2. And therefore, if you're going to get by Pythagorean theorem, the hypotenuse, that is 4 plus x squared, of which this is now our integrand here. Okay, this is very important. Okay, so as to know what will be the sides of your triangle. Okay, well, of course, trigonometric substitution, we already got the x. So we can substitute it here, x squared, by simply squaring this. But the problem is we still need to get dx and the square root of 4 plus x squared. So we can get dx by simply differentiating this both sides. So differentiating it to the left with respect to x and differentiating this with respect to z. So if we get the derivative of x is equal to 2 tangent z, that must be dx is equal to what? 2 secant squared z with respect to z. So we have to include dz. So we get now the dx. And how are we going to get the square root of 4 plus x squared? Well, by looking at this triangle. Okay? So as much as possible, we want to try to avoid this side which has an x. Okay? So we're going to try to avoid this using this side, okay, with respect to z. Okay, so in avoiding this, we cannot use sine because sine has an opposite. We cannot use also cosecant because it has an opposite. Okay? So we can use cosine. Cosine of z. Cosine of z is adjacent over hypotenuse. But if you're going to look at our x and dx, it is in terms of tangent, in terms of secant. So we can use the secant function. How? By reciprocating the cosine. Because 1 over cosine is secant. And if we reciprocate that, instead of adjacent over hypotenuse for a cosine, so secant z now will be what? Hypotenuse over adjacent. So hypotenuse will be 4 square root of 4 plus x squared, okay, over 2. And if we're going to get square root of 4 plus x squared, because that's what we are after to make a substitution, that is 2 secant z. Okay, we're done here. So we have the x, we have the dx, and we have the square root of 4 plus x squared. So we can substitute it to our integral now. Our integral will now be dx is simply what? 2 secant squared z dz. So 2 secant squared z dz over x squared. So we have to square this. We have to square this side. Okay, we have to square this side. And upon squaring that, so 4, that would become 4 tangent squared z multiplied by the square root of 4 plus x squared, which is actually 2 secant z. So 2 secant z. So what will happen is that by simplifying our integral, we could cancel out this 1 secant here, and also, of course, the 2, okay? And 2 secant here will be cancelled also, okay? So cancel, cancel. So we are left with secant z. So let me just rewrite it here so that you can see it. We can save some space. So that's the integral of what? Secant of z dz over 4 tangent squared z. So we can factor out 1/4 outside of the integral, and we are left with secant z dz over tangent squared z. And if we can simplify that, 1/4, the integral, secant z is 1 over cosine z by reciprocal identity, and tangent squared z is simply sine squared z over cosine squared z, and that is basically still dz. So if we're going to get the reciprocal of the denominator and perform multiplication, we can get what? 1 over cosine of z multiplied by cosine squared z over sine squared z dz. And as you can see here, 1 cosine here will cancel. So this would be cancelled. So we are left with 1/4 integral of cosine of z over sine squared z dz. And this is a very pretty much for straightforward integral. If we're going to rearrange this, so we have 1/4 integral of sine z raised to negative 2, okay, raised to negative 2, multiplied by cosine of z dz. So you can see here we can let u as sine z and du is cosine z dz. Okay, so we can transform that into 1/4 the integral of u raised to negative 2 dot du, so that we have now 1/4 u raised to negative 1 over negative 1 plus c. So that should be 1 over 4 u, 1 over 4u, okay, negative 1 over 4u because we have a negative 1 here, plus c, and substituting back u, that should be negative 1 over 4 sine of z plus c. So this is not the final answer because this is actually expressed still in terms of z. Our original integral is in terms of x. So what are we going to do is to eliminate this sine z by looking at our triangle here. Okay? So sine z, based from our triangle here, so we're going to evaluate sine z. Okay? Sine z is equal to opposite over hypotenuse. Okay? So, opposite is x, hypotenuse is square root of 4 plus x squared. So, sine z would simply be equal to what? Negative 1 over 4. And again, that is equal to x over square root of 4 plus x squared. So, this is x over square root of 4 plus x squared. Okay? Plus c. And to simplify, we can get what? Negative of square root of 4 plus x squared over 4x plus c. Let me just rewrite this negative more neatly here. And this is our final answer. So basically, that is problem number 1. For number 2 problem, okay, example number 2, we have now number 2, that is the integral of x squared over square root of x squared minus 4 dx. Okay? Square root of x squared minus 4 dx. So, looking at our formula, we have the form of square root of x squared minus some a squared. So, looking at our formula, square root of x squared minus a squared is this. Because our x squared, the coefficient value is 1, so we can use this. We have to substitute a secant of z. X is equals to a secant of z. So, we have to let x is equals to a secant of z. And x now will become a. What is our a here? Okay, the a here is 2. Again, a squared is 4. So, secant of z. And again, we can derive the triangle using this equation by isolating secant z. We have x over 2. Secant z is equals to x over 2. And by drawing another right triangle here, okay, we can locate, this is the z, This is the side of hypotenuse. So secant of z is equals to x over 2. The reciprocal of secant, 1 over secant is cosine. And cosine is defined as ka adjacent over hypotenuse. So if you're going to reciprocate that, hypotenuse over adjacent. So secant will now be hypotenuse, this is our hypotenuse, x, over adjacent side, this is 2. And you can expect that this side, actually, by Pythagorean theorem again, is x squared minus 4, which is again our part of the integral. Okay? So, what do we do next? Again, yes, we're going to get the derivative. Okay? We're going to get the derivative of this. So, in order for us to replace dx, so dx will now be derivative of 2 secant z is 2 secant z tangent z dz. Okay? So, 2 secant z of you cannot see. I think you cannot see. I will just rewrite it here. Okay? Dx is actually 2 secant z tangent z dz. Okay? And we have now the dx. We now have the x squared. We're going to simply square this. And we should get square root of x squared minus 4. And again, looking at the triangle, we should avoid using the side with an x. So we have to avoid the hypotenuse. So what are we going to do? We're going to use this function, only the adjacent and the opposite. So we can use what? Since it has tangent here, so we can use the tangent function. Tangent of z is simply TOA, opposite over adjacent. So the opposite of this z is side is x square root of x squared minus 4 and its adjacent is 2. So TOA is simply square root of x squared minus 4 over 2, and we can get square root of x squared minus 4. Square root of x squared minus 4 is 2 tangent of z. And now we can replace our integral. Okay? We're going to replace our integral. We can now have what? Let me just make a space here. Okay? Okay? So we can replace the integral by simply what? X squared is, we have to square the x, this x squared. So we have 4 secant squared z over square root of x squared minus 4, that is equivalent to 2 tangent of z. Okay? Multiplied by dx, and our dx is simply this, 2 secant z tangent z, 2 secant z tangent z dz. As you can see here, 2 tangent z will cancelled by this, okay? And you are left with the numerator, what? Integral of what? 4 secant squared z times secant z is secant cube z dz. Okay? So that is now our integral. So we can integrate this using integration by parts. So we have now integral of, let's say that is 4 integral of, we can factor out 4 because it's a constant. So secant squared z multiplied by secant z dz. And we can choose u as this secant squared z or secant z. Okay, so it doesn't matter because it's the same. So getting du here, and the derivative of this is secant z tangent z, and of course dz, and of course our dv would now be the remaining, okay, which is actually secant squared dz. So in u we use only secant z because this is already readily integrable. Okay, so dv is secant squared z dz, and if we integrate that both sides, we have v now is equals to the integral of this is basically tangent z. Okay, tangent z. And applying the formula u v minus v du, we have now what? 4 the multiplied by, again, let me just rewrite the formula, u v minus the integral of v du. That is our formula for integration by parts. We have 4 times the u times v U is secant z times V, secant z tangent z, agree? Secant z tangent z, minus the integral of the V, which is tangent z, tangent z, then du, which is secant z times tangent z dz. Okay, uv minus v du, integral of v du. Okay, so what will happen here is that we have 4 secant of z tangent of z minus, we can combine the tangent squared. Okay, tangent squared z times secant z dz. And from here, we can use actually convert this into tangent squared z. Remember, tangent squared z is equal to secant squared z minus 1 by this identity. So we have now, we have to distribute 4. Can we distribute? Yes, 4 secant z tangent of z minus 4, okay, integral of what? Secant squared z minus 1, because that is equivalent to tangent squared z, multiplied by secant z dz. Okay? So, I'm sorry. Okay? So again, by techniques, we have 4 secant z tangent of z. And basically, what? If we distribute this secant z to this, we will be having minus 4 the integral of secant cube z minus secant z, and that is integrated by dz. As you can see here, we can distribute the integral. So we have 4 secant of z tangent of z minus 4, of course, the integral of secant cube z dz. Okay? Let me just distribute again the negative 4. So this would become what? Of course, this would become negative 4 integral of secant cube z dz minus 4, okay, minus 4, okay, minus negative 4 times negative will become positive 4 secant of z dz. Okay, we have distributed the 4 here. Okay, so this become positive because negative 4 times this negative will be positive. Okay, so as you can see here, our integral yields to this again, secant cube of z dz, wherein, of course, we started with that again. Of course, this is our original integral. Okay, and we return back to this. So basically, okay, let's copy this side. Okay, let's copy to end this integral. To end this integral, okay, we're going to copy that. So that is equal to 4 integral of secant cube z dz, and it is equal to this integral. Agree? Because this integral came up when we used IBP on this integral. So this must be equal. Okay, minus 4 integral of secant cube z dz plus 4 integral of secant z dz. What are we going to do to eliminate this? Because this will lead to an unlimited IBP. We're going to add plus 4 integral of secant cube z dz on both sides of our equation. Plus 4 integral of secant cube z dz. Okay, what you add on the left is what you add on the right side. So this would now become 0. Okay, and here, if you're going to add this, we have now 8 integral of secant cube z dz, and that is equivalent to 4 secant z tangent z plus 4 integral of secant of z dz. Okay, and what are we going to do? 4 secant of z tangent of z. Can we integrate this secant? Okay, What is the integral of the secant? Oops. The integral of secant is actually what? 4 ln of secant of z plus tangent of z plus c. And as you can see here, the right side is equivalent to 8 secant z dz. But what we are after is actually not this. We are after for the integral of what? The integral of 4 secant cube z. Or this factor of 4 outside the integral. We are after that. So we have to make this left equation equal to 4 secant cube z. So what are we going to do? By simply dividing both sides by what? By 2 actually. So if we divide that, this would now become our original integral a while ago, secant 4 secant cube z dz. So 4 over 2 is 2 secant z tangent z plus 4 over 2, that is 2 ln of secant z plus tangent z plus c. Now, this is not our final answer because we have to what? To translate this z into x again. And again, what are we going to do? We need secant z and tangent z at least. What we're going to do, we're going to get back on this triangle. Okay? So again, we already got the secant z. And secant z is equal to x over 2. And tangent z is square root of x squared minus 4 over 2 here. Okay? So secant z is x over 2. So we have here 2 times the x over 2. Those 2 will cancel. Times the tangent z. Tangent z is equal to x squared minus 4. Okay? If I'm not mistaken, is that minus 4? Okay? X squared minus 4 over 2. Okay, over 2. Over 2 plus 2 ln of the absolute value of secant z is x over 2 plus square root of x squared minus 4 over 2 plus c. And simplifying, we have now 1/2 of x multiplied by x squared minus 4 plus 2 ln, the absolute value, since they have the same denominator, we can simply add them. It's x plus x squared, square root of x squared minus 4 over 2 plus c. And this should be our final answer. Okay? Okay, for our third example, we have to get the integral of the square root of 9 minus 4x squared over x, oops, over x multiplied by dx. Okay, and again, you're going to look back. We're going to look back on our formula a while ago. If you copied it, you must copy it. So what will happen, class, is that this integral has a form of what? A form of a squared minus b squared x squared. And this is basically equal to what? X is equals to a over b sine z. Okay? So we're going to use this equation. So our x would be simply what? Our a here in this case is not 9 but 3 over not 4 but 2. 3 halves sine z. And well, of course, again, we're going to derive our triangle from this equation so that if we're going to get the sine of z, that is equal to 2x over 3. And if we're going to draw the triangle, right triangle of that, so now we have, this is the hypotenuse side, this is sine z, so this will be our angle z here. So z is, so opposite is 2x, opposite side of z is 2x, this is the opposite side, over hypotenuse is 3. So that this side, this adjacent side is now, I'm pretty much sure that that is square root of 9 minus 4x squared. Okay? So, and again, we're going to get the dx. Dx is Derivative of 3 halves sine z is 3 halves cosine of z. And again, we're going to get square root of 9 minus 4x squared. So as you can see here, as much as possible, in this triangle, we have to avoid the term that has an x, which is this side, opposite to angle z. Okay, so we're going to use either this and this side. So adjacent and hypotenuse. So based on our x and dx, we can use the cosine function. So for us to be consistent, cosine z is adjacent over hypotenuse. So the adjacent side of z is 9 minus 4x squared over the hypotenuse is 3. So that if we're going to get square root of 9 minus 4x squared, and that is simply equal to 3 cosine of z. And now, we can substitute it to our integral. Okay? So our integral will now be, okay, our integral will now be square root of 9 minus 4x squared is 3 cosine of z over what? The x value, that is 3 halves sine of z, and the dz or dx is equal to 3 halves cosine of z dz. This has a dz. Okay? So what happens is 3 halves will cancel. Okay? So that we have now the integral of 3 cosine squared z, cosine times cosine, cosine squared z over sine z dz. We can factor out 3 outside of the integral. 3 integral of cosine squared z is equal to 1 minus sine squared z over sine z dz. And we can factor out basically the integral here. We can separate. So we have 3 multiplied by the integral of 1 over sine of z dz minus the integral of sine squared z over sine of z dz. So as you can see, sine squared will be cancelled by this sign on the denominator. So we have now 3 integral of 1 over sine. 1 over sine is equal to cosecant z dz. Okay? Again, minus the integral of sine z dz. To integrate that, so integral of cosecant is ln absolute value of cosecant z minus cotangent z minus, okay, the integral of sine z is negative cosine z. So negative cosine z times the negative will become positive, and we are going to distribute 3 here, so that would be plus 3 cosine of z plus c. Of course, this is not our final answer, so we need to get cosecant z and cotangent z and cosine z. Well, of course, in our what? In our triangle. So we have now already the cosine z. So we should get cosecant and cotangent. So we have here sine of z. So to get cosecant of z, simply we need to get the reciprocal of this. Okay, so the reciprocal of this is 3 over 2x. So 3 ln cosecant z is simply equal to 3 over 2x minus cotangent z. Cotangent z is basically, if tangent is TOA, opposite over adjacent, cotangent is adjacent over opposite. So that should be the cotangent of z, okay, is simply adjacent na square root of 9 minus 4x squared over opposite over 2x. So we can substitute it here. So cotangent z is square root of 9 minus 4x squared over 2x plus 3 cosine z. Cosine z from our figure here, or from this, is equivalent to square root of 9 minus 4x squared over 3. So we have square root of 9 minus 4x squared over 3 plus c. Simplifying, 3's will cancel. Okay, so we have now the final answer as 3 ln absolute value of 3 minus the square root of 9 minus 4x squared over 2x plus the square root of 9 minus 4x squared plus c. And that should be our final answer. Okay? So for number 4, by the way, this video has 5 problems so that you will be really practiced. Okay? For number 4, what are we going to do is find the integral of dx over x times the square root of 9 plus 4x squared. Okay? And if you're going to look at our formula, this is a form of square root of a squared, okay? Square root of a squared plus b squared, okay? Because we have here a coefficient of x that is not equal to 1. So we have to include b squared x squared. And this is actually equivalent to x is equals to a over b tangent of z. Okay? So if we're going to let x is equals to a over b, our a here is not 9 but 3. Our b here is 2 tangent of z. And again, from this equation, we're going to derive the triangle. So tangent of z is equal to 2x cross multiplication over 3. So if we're going to draw our triangle here, okay, so this is our z. So tangent is TOA, opposite side is 2x over adjacent is 3. So therefore, this side is 9 plus 4x squared. Okay? So, and again, after that, we're going to derivative or get a derivative of this x with respect to x on the left side and with respect to z on the other side. 3 halves. The derivative of tangent z is secant squared z dz. And of course, what we are after, we get the x, we get the dx, and we have to get the square root of 9 plus 4x squared based on this triangle. And as much as possible, we want to, what? Not to use this side, which is the opposite side of the z. Okay? So we're going to use the adjacent and the hypotenuse. So adjacent over hypotenuse is what? Cosine. And hypotenuse over adjacent is secant. Okay, because 1 over cosine is secant. So we have to use the secant function. So the secant of z is what? Cosine adjacent over hypotenuse. So secant is hypotenuse over adjacent. 9 plus 4x squared. Hypotenuse over adjacent, which is 3. In order for us to get square root of 9 plus 4x squared, so that is 3 secant of z. So now we can perform our substitution, trigonometric substitution. That is equal to integral of dx, that the dx is 3 halves secant squared z dz. Okay, over the x, what is our x? Is 3 halves tangent z. Multiply it by square root of 9 plus 4x squared, which is 3 secant z. 3 secant of z. So as you can see, 3 halves will cancel. And of course, the secant here, one term of secant here will cancel with this. So that you are left with the integral of secant of z dz over what? 3 tangent of z. So we can factor out 1/3 integral of secant of z dz over tangent z. So again, using some identities, we have now 1/3. The integral of 1 over secant is 1 over cosine of z divided by tangent is sine of z over cosine of z dz. And if you're going to cross multiply or to get the reciprocal and multiply it, so we have 1 over cosine z multiplied by cosine of z over sine z dz. So as you can see, cosine z will cancel. So we have now what? 1/3 of the integral of 1 over sine of z dz. And 1 over sine is cosecant. So cosecant cosecant of z, cosecant of z dz. And what will happen is the integral of cosecant is 1/3 ln of the cosecant of z minus cotangent of z plus c. That is not our final answer. We have to get cosecant in terms of this triangle. Okay? And we have to get also the cotangent. Okay, we have the tangent. We're going to simply get the reciprocal of that. And for cosecant, we're going to get the sine, okay, function. So the sine function is opposite over hypotenuse, but its reciprocal is hypotenuse. So cosecant z will now be hypotenuse over opposite. So hypotenuse over opposite, which is 2x. Okay, cosecant z is that value. So 1/3 ln of the absolute value of the square root of 9 plus 4x squared over 2x minus the cotangent of x is simply the reciprocal of the tangent function here, 3 over 2x. So 3 over 2x absolute value plus c. So 1/3 ln of the absolute value of square root of 9 plus 4x squared, square root of 9 minus 4x squared. Let me just rewrite. Minus 3 over 2x plus c. And this shall be our final answer for the integral. Okay. So down to our last example. This is the last example for this video. 5 is the integral of the square root of 25x squared minus 4 over, let me just rewrite, over x dx. X and dx here. So as you can see, this has a form of the square root of b squared x squared minus a squared. And if we're going to go back to our formula, we would be using x is equals to a over b secant of z. So going back to our formula, okay, if we go back to our formula here, that should be this. Okay. So again, the same process. We have x equals to, our a here is not 5, but rather the 2 over what? 25, not that, because that is b squared. So the b of that is 5 secant of z. And of course, from that, we can derive the secant of z. Secant of z is 5x over 2. And from that, we can derive our right triangle. Okay, this is our side z, or the angle z. So secant is the opposite of cosine, wherein cosine is adjacent over hypotenuse. So this should be hypotenuse over adjacent. So our hypotenuse is 5x, adjacent side is 2, and therefore this must be 25x squared minus 4, okay, by Pythagorean theorem. And what are we going to do again is to get the derivative of x here, and the derivative of this, 2/5 secant of z tangent z dz. And of course, we're going to get this term, okay, square root of 25x squared minus 4 using our triangle. So as you can see here, we cannot use hypotenuse because it has a term x. So as much as possible, we don't want to use that. So we can only use adjacent and opposite. So we can use the tangent function. Tangent of z is opposite over adjacent. Okay, TOA, opposite is square root of 25x squared minus 4 over 2. Cross multiplying, we have square root of 25x squared minus 4 is equals to 2 tangent of a z. And therefore, we can now solve our integral. So that integral is equal to square root of x squared minus 4 is simply equal to 2 tangent z. 2 tangent of z over x, which is here, 2/5 of secant z, multiplied by dx. Our dx is 2/5 secant z, tangent z, dz. So as you can see here, 2/5 will cancel as well as the secant. Okay. Then we are left with what? 2 tangent z times tangent z is, we can factor out 2, the integral of tangent squared z dz. So we can what? We can actually transpose or transform this tangent squared z into secant squared z minus 1 is equals to tangent squared z for us to integrate this. So we have 2 integral of secant squared z minus 1 times dz. Well, of course, we can integrate this, okay, independently. So integral of secant squared z dz minus dz simply. Okay, so integrating that, we have 2 integral of secant squared is tangent of z minus integral of dz is simply z plus c. Right, and going back to substitute this z into x, so our tangent z is equals to square root of 25x squared minus 4 over 2. So we have 2 what? 2 times square root of 25x squared minus 4 over ba yun? 2 ba yun? Yes, that is 2. Okay, 2. And these 2's will cancel. Minus z. We don't know the z. Okay? So we can, based on the choices, we can pick the z as the, we can get the z by this trigonometric function. Okay? Based on the choices. So in this case, I'm going to use cosine of z. Cosine of z is ka. Okay? Adjacent over what? Adjacent over hypotenuse. So 2 over 5x. Okay? So rearranging this, we can get arc, we can get z. We can get z by what? Okay? Z is arc cosine of 2 over 5x, and that should be our z. Okay? So z is arc cosine of 2 over 5x. So arc cosine of 2 over 5x plus c. And again, you can get the z in different trigonometric function based on the choices. But of course, I only use the cosine function, so you are not limited to do that. You can use tangent or whatsoever you want. Okay. So this would be resulting into square root of 25x squared minus 4 minus the arc cosine of 2 over 5x plus c. And of course, okay, we forgotten to distribute 2 here. So this should have also a 2. Okay, I'm sorry. So we have negative 2z here. So this should have a 2. Because again, we try to distribute this 2. So this should have a 2 here and here. Also. So our final answer would be square root of 25x squared minus 4. Okay, minus 2. Okay, minus 2 arc cosine of 2 over 5x plus c. Okay, and again, we distribute the 2 here. The 2 factor 2 here in our integral. So thank you so much for listening, and I hope you learned something today, and that is a very exhausting lecture, and I do hope you learned something today. Thank you so much, and God bless you.